Morning. Today we are going to talk about finding zeros of polynomials. We actually did a little bit of this in 3.3. We're just going to learn a couple of new techniques, especially for a test to determine possible rational zeros. Okay, so why don't we first take a look at this example and see what kind of zeros can we obtain once you factor a polynomial and set it into 0? Okay, there is a very long polynomial given here with degree 6 or highest exponent 6, and zeros can be determined once you factor this polynomial into simplest factors and set each piece into 0. And thank God somebody did it for us. They have factored this polynomial into how many pieces? 1, 2, 3, 4, 5, 6. Some of them have only whole numbers. Some have, once you set into 0, rational numbers or fractions. Some has square roots and some have complex numbers. So the story here telling us is not all zeros are perfectly whole numbers. I wish every polynomial has zeros like this, x minus 1, and that's what kind of zeros we dealt with in 3.3 last time on Friday. Unfortunately, some of the factors, when you set into 0, subtract 7 and divide by 2, you will end up with negative 7 over 2. It's a fraction, okay, or decimal. It's going to be a decimal number or fraction. It's not a whole number, okay, but these two are still okay. These are still, we are okay. These are good zeros. They are easy to obtain kind of zeros. We call them rational zeros. Well, when it comes to square roots or complex numbers such as this one, look, negative root 3, positive root 3, when you set them into 0, you get root 3 and negative root 3. These are kind of hard to obtain, okay? So these require extra challenges or steps, but at least I'm expecting, or we are expected to find these rational zeros easily. Once you get the rational zeros, since your polynomial will shrink to so small size, we can guess or find out the remaining irrational zeros and also non-real zeros. So again, complex numbers are called non-real numbers, but irrational numbers are still real numbers, root 3 and minus root 3. I mean, they turn into decimal, never-ending decimal. But the easy target for us is get rational zeros first. We first obtain rational zeros, and then we try to obtain irrational zeros, and finally, if there is any, we try to get complex or non-real zeros. So this rarely happens. This sometimes happens, and rational zeros happens a lot. This is most frequently happens. So we will first learn how to get rational zeros, whole numbers or fractions. Okay? There is a test for determining possible rational zeros. Okay, I want to mark this word. This is a rational zero theorem, but it's true for finding possible rational zeros. It's not going to give you the entire exact list of rational zeros. So there will be some fake ones you need to identify and take it out of the list. Okay. So what is this test, or what is this theorem telling us? It tells us that if you want to compile a list of possible candidates for rational zeros, all you need to do is divide two numbers. What two numbers? Those two, first number comes from a factor of the last number in the polynomial. We call it constant number. So you take the last number, which is the constant number, and you take the first number, which is the leading term. Okay, so you take these two, constant term and leading term, leading coefficient. You simply check out their factors and couple those factors, one in the numerator, one in the denominator. Again, this has been a little bit confusing, but you first determine the last and very first numbers in the polynomial. They are called constant term and leading coefficient respectively. Then, are we taking these exact same numbers in and divide them? No, we are not taking a0 and an. You see, they call it p over q. You take a factor of the last number and a factor of the first number, leading coefficient number, and you divide them. So this way you get many options, because there may be several factors of the last number, there may be several factors of the initial number. You divide them. Okay, so it will make better sense if we show it on an example. So here is our example, or first question as well. You are going to determine the list of possible. Again, I want to mark this. It's not asking for exact rational zeros. Just give me a list of possible zeros so you can hunt there. This is your hunting ground. You're going to later hunt and get the exact correct rational zeros. So what is that list? That list will be consisting of p over q's. P is the factors of minus 10. So you're going to list the factors of minus 10 here. And that will be divided by factors of leading coefficient, factors of constant term. Okay, so all you need to do is tell me what numbers divide 10. What numbers divide 10? Oh, by the way, should we consider negative sign? No, you can forget about negative sign. Just break number 10 into factors. What numbers divide 10? What is the smallest number that divides 10? 1. We start with 1. Good. What is the another one? What is another one? 2. And there is 2 more. 5. What? Itself. Perfect. We take the number 1 and 10 itself. Usually when I say what is factors of 15, we always do only numbers different than 15, 3 and 5. But no, for this work test, you also take the number itself and 1. Usually when I call factors, 1 and the number itself doesn't count, but here it counts. Alright, Q. Q is the number in the very front side, leading coefficient, that's what we call. And you are going to break that number into factors. Start with, again, 1, 2, and 4 itself. Right? Are there any more? Okay. What are we gonna do is, when we are building this set, list of candidates, now, list of candidate possibles, or possible zeros is the better word. You're gonna compile a list here and separate them with a comma. Always you will take one term from the top, one number from the top, and check out each possible division by 1, 2, 4, each number from the bottom. So what is 1 over 1? 1. That's the first one. 1 over 1, this couple makes 1. But not only 1, but also consider the opposite sign as well. So it could be -1 if one of them is negative as well, because I left out the negative sign when I'm considering this division. So these numbers P or Q may have negative options as well. So negative number 1, positive number 1, maybe -1 in the result. So always once you have a number candidate here, put plus and minus. There are two candidates now. The second one, 1 and 2 makes, 1 and 2 is 1/2, plus and minus again. Third, 1/4, 1 and 4, plus minus 1/4, right? We're done with the 1. Who's next? We are going for 2 now. 2 goes into 1, 2 goes into 2, 2 goes into 4. What is 2/1? 2/1 is plus minus 2. What is 2/2? You may put 2/2 here, but now reduce it. Reduce 2/2, which is 1. So shall we repeat 1 again? No, it was already obtained before. So this is nothing new. So we don't count 2/2 in the new list. It's already been counted. 2/4. Shall we put 2/4? It's the same as 1/2. No, again. So there is only one new component or candidate showed up from two sides. Let's go to 5. 5 goes into 1, 5 goes into 2, 5 goes into 4. I think they're all brand new, right? Plus minus 1, plus minus 5, plus minus 5/2, plus minus 5/4. Okay? Next, 10. 10 goes into 1, 10 goes into 2, 10 goes into 4. How many new different ones do we get? 10/1 is the first one. And then 10/2, which is 5 again, so we don't double count. And 10/4, is it new? 10/4? No, 10/4 is the same as 5/2 when you reduce. So this is it. Again, I will mark this one more time. Most people think these are zeros. When you enter these numbers into X's, they think this is gonna make 0. No, it's not. These are just possibilities. 1, 2, 3, 4, 5, 6, 7, 8 times 2. There are 16 candidates running for this race. They are going for, they can be zeros. But are all of them zeros? No, we can maybe have 1 out of 16 making this thing 0, or maybe 10. We need to test them. Are we supposed to test in this section question? No, it just says find or list the possible zeros. We will just list this and we're done. In your homework though, you're already been given options, so you just need to pick the ones that show up on your list. 2/25, is it in your list? No. Plus minus 10? Yes. Plus minus 1/2? Yes. Yes. How about 4? No. Plus minus 2? Yes. 5/2? Yes. 5/4? Yes, it's here. And 1/4? Yes. Plus minus 5? Yes. Only 2 are not in our list, right? Any questions? Okay. Alright, now we know what to do next. In the next question they will ask, find those those exact rational zeros. So we are going to go for a hunting in this pool. We will fish out those real correct rational zeros. It's coming up here next. It says find all of the zeros, all of them. So we first check for search for rational ones because they are easy target, right? So let's dig for rational zeros. I need to make a list first. So P over Q list. What are the possible P and Q's? So tell me the factors of P's are the factors of 3's. So what are they? 1 and 3 only, right? Plus, minus. No, we don't have to put plus minus here. We can do it afterwards. How about Q? It's just 1. Wow, this is an easy question, isn't it? Because how many possible zeros do you have? 1 over 1 is the first one, so there are 2 possibilities here. And then 3 over 1, which is plus minus 3. So we have 4 candidates that can be possibly rational zeros. So it's gonna be an easy one, easy hunt. Okay? Alright, now how do we check these are really zeros? Yeah, the book says to check whether these are zeros of the function, that it makes its function 0, make synthetic division, because a 0 will have 0 remainder once division performed. So to test, for example, x equal minus 1 is a 0 or not, you need to test it by synthetic division. Okay? To test 1 is a 0, you need to test by synthetic division. That's, I feel, a little bit long. It's okay, you can still do. What is another alternative if you want to test it's 0 or not? So I will first test, for example, x equal 1. Let's test x equal 1. Okay, so how do you do this with synthetic division? Are we going to take opposite of this number? No. Testing x equal 1, 0 or not means x minus divide the polynomial or not. Okay? So in other words, you're testing x minus 1 is a factor or not, and if it's x minus 1, we take opposite of it, it's this original number. So when you're testing a 0, you don't flip the sign, you just take that number as it is. Okay, what do I put in the dividend sign? Here I put all these numbers, right? Correct? So I start with 1. I continue with minus 7. Next I have 11. And finally I have 3. Okay? Alright. I bring this down. We multiply out always, put it here and add these two numbers together. 1 times 1 is 1. Minus 7 plus 1 is minus 6. We multiply and put it here. 1 times minus 6 is negative 6. 11 negative 6 is 5. 5, 8. So what is the verdict? Is x equal 1 a 0? No. Is not a 0. Okay, you see, this is kind of time consuming. If you want to save time, what's the other way to test whether 1 is a 0 or not? Plug it in, see if it makes 0, right? Doesn't it make sense? So really, take that polynomial called mx and compute m of 1, which is, what is the equation? X cubed, that's x cubed, so it's 1 cubed. So this is kind of cheating. This is not book is doing, but I find it useful. Minus 7, 1 squared. I just want to double check. And then 11 times 1 plus 3. And this thing is 14 minus 7 plus 1 is 8. As you see, we got the same thing. So 1 is not 0 again. Same conclusion. Okay? Got it? Alright, who do you want to test next? Unfortunately, if you're unlucky, you start with the wrong number and keep picking the wrong ones. It may take a while until you catch the real fish. We haven't caught the first one. The second one you want to test is, which one you want to test? So again, there are 4 terms here. I have tested this one out. Fake one. It's not a 0. What is the next one you want to test? Negative 1. Okay, I will test on the function, okay? Looks like we have a 0 here. No, we don't. Minus 11, minus 7. Nope, this is not 0. X equal minus 1 is not a 0 as well. We are unlucky. We keep picking the wrong fishes. Get the real one. There are only 2 left in the pool, right? I bet the next one is gonna make it. I hope. So test x equal positive or negative. Which one you want to test? Let's test 3. Okay. This time I want to do synthetic division. I mean, when you are really used to synthetic division, it doesn't take too long. I mean, really. 1, 3, minus 4. Look how fast this is. I mean, it didn't take any more than this, right? So it's not too bad. It's not too bad. I don't want you to quit doing this and do this. Do this. Because the work here, once you catch the fish, the work here done is actually going to be used in the process next. So you have to do the synthetic division anyways. Okay? So what did I do here? What did I get? This is remainder. If the remainder is 0, what is the verdict? X equal 3 is a 0. I promised you the work you've done here is going to be used for what? Now you caught the fish. You caught one of the zeros. But did you find them all? Did you find them all? No. Once you get the first one, oh, are you gonna test the next one? So we tested this one out. This is fine. This one was fake. Are you gonna test the last one? No, which one did we test? X equal 3, right? So we tested this one. Are you gonna test the middle one? This one, minus 3? No, you don't have to test it. It's not required at this moment. Why? Once you catch a fish, we've caught one, right? Use it as a bait to catch the next one. How? Like the past example from Friday. If you know 9 is a factor, or 0 of 81 is a factor of 81, how do you catch the other part? By dividing both sides by 9, right? Dividing 81 by 9, correct? Or make an simpler example. If I say 21 and you caught the 3 first fish. This is the entire polynomial. You caught the first one. How do you catch the other ones? How do you get the other factors? We divide both sides, 21 by 3. So we will do the same thing. If x equal 3 is a 0, let's divide the entire polynomial by 3. What is the quotient will be? Look at this. When you are testing, you actually found that quotient, the result of division. This is 7. 7 is here, in other words, the other factors. So how do we use this information? This is how you use it. The polynomial we are given is x cubed minus 7x squared plus 11x plus 3, right? We just discovered that the first factor for this polynomial is x minus 3. We just figured it out. But what are the remaining fishes? Where are they? They are here. 1, minus 1, and 1, minus 4, and minus 1. How do you write this up? Every time you go left, you put a raised power of x. You raise the power of x by 1. First power, second power. So the missing part is this guy now. So x equal 3, we already know, a 0. What are the other zeros? It's here. The other zeros will come from this part. So you need to factor this guy. Are you going to factor this again by P over Q test, catching and making another possible zeros list and catching fishes from there? You can do it. It's possible. It works, but it's just too long. This is called a quadratic function. Quadratic or square function. Can you factor this manually by hand? Can you? All you need to do is guess two numbers that splits up. Can you guess it though? Sometimes it's easy, you can guess it, sometimes it's not. Right? Can you guess two numbers multiplying into minus 1 and adding to minus 4x here? I know the first pieces are x's, but what are the others? Any comments? Any responses? What two numbers multiply into x squared minus 4x minus 1? Ashley? Looks like you have an idea. No? 1 and 4? Does it work? 1 and 4? No, they don't multiply to minus 1. Madison? Okay, Madison. No? You guys can't come up with a pair? Yeah, you're right. I can't find any easy whole numbers multiplying into minus 1 and minus 4. I wish this one was... No, I can't factor this. I wish this was... I was gonna say 2, but this is negative. It's not even working. So I can't manually factor a quadratic function. Then what do I do? Do we quit? Manual work doesn't work. And how do you find zeros of a quadratic function? Imagine you set this into 0 and somebody wants what x values makes this thing 0. So then what do? I can't break it up, but I need to find out their zeros. Anyone? Maddie? We use quadratic formula to find zeros of this thing. If it's not easy breakup, you can't do on top of your head, then do this formula. It's minus b plus minus square root b squared minus 4ac over 2a. What is b? B is this thing. It's going on here, and that's going in here as well. C is this number. It's going in here. A is this number. It goes into both places, one on the top, one on the bottom. Okay? Make sense? Alright, let's compute those values. Those are gonna be for x. It's minus b, which is minus 4. Let me know if you see a mistake or something. B squared is minus 4 squared. Minus 4, a is 1, and c is minus 1.
Shouldn't it be positive at the beginning?
Perfect. Because we already have a negative, and this has an extra negative. Double negatives makes this positive 4. More mistakes?
Right.
We need a parenthesis here. Unless you put a parenthesis, minus 4 becomes minus 16. But once I put a minus sign here, parenthesis here, this turns into positive 16. That's the correct way. That should be positive 16. The bottom is twice 1. Correct? Alright, let's get those computed if possible. 16 plus, by the way, we start from this part. Multiply these three numbers and put it here next to 16. What is negative 4 times 1 times negative 1? Positive 4. And they make 20. I don't want to put here 20. Instead, I want to break that 20 as 4 and 5. Guess why? Do you know why I broke 20? This was 20. Do you? Why didn't I just say 20 here? Chris, do you know?
So you can reduce it?
Yeah, we can reduce this by moving 4 out, because 4 is a perfect square. It's square of 2. So 4 comes out of this prison as 2 in front here. And 5 is stuck there forever. And are we done? This is it. There is one more reduction. Do you see that? Do you? No? Should I enter this as an answer? If you don't reduce all the way, it's gonna say incorrect. If you don't trust me, we can test. Look, we found, it looks like you found 2 here. There is another one, third one. So the zeros are 3. This one is 3. And these two guys, you may say once with a positive, once with a negative option. There are 2 more. I'm putting this in if you're not fixing anything. Do you see? Yeah, Chris?
Divide by 2.
We need to divide by 2 and make this thing 2. Is that right?
Yeah.
That's not right. We need to divide this one by 2 as well. This 2 not only divides 4 but also 2 root 5. It's a denominator of an addition. That means you need to divide each and every term on the top by 2. So the correct solution is 2 root 5, 2 minus root 5. Okay? This is the most reduced form. Try to enter this as an answer. It will probably say incorrect because it wants you to go all the way to the reduced case. Alright, we got 3 roots. I keep calling them roots, but they are 0, okay? They are called 0. 3, 2 plus square root 5, comma, 2 minus root 5. Check. Perfect. Okay. Do not attempt to change this into decimal. Some people take it calculator and put root 5 into calculator, add 2, turn it into decimal, but root 5 is a never-ending number. It's 2 point something. If you cut it off and put, it's an approximate answer, and the computer won't like it. We want exact solution. Any questions about this process? Let me repeat what we did. We first hunt for rational zeros. The hunt was actually over here. It was over right at this moment. We found the list, pool of candidates. Then we started eliminating this, and we actually found our prey. And then once we get that guy, first one, we use it as a bait and got the other two roots or zeros, but they are going to be non-rational one, irrational one. They turned out to be square root ones, and we found it by quadratic formula. If this was a cube, I was doomed. I'm glad it's not a cube. It was a square. I knew how to find zeros of such things by quadratic formula, so we were lucky. Alright, next. It's a bigger challenge now, because why? Compared to the previous question, you had the biggest exponent 3 here, and the biggest exponent is 4. It's the next level. I'm expecting more zeros or more work to get them, okay? Because this is a longer or higher degree polynomial. Alright, we first hunt for rationals. Oh, we're lucky. They don't want the end. No, they want the whole zeros. But in the first step, they just want the rational zeros. Let me double check. What do you want really here? So read the statement, because sometimes what they demand may be less. They say find all the zeros, but here they are only asking for rational zeros. So we can stop once we find the rational ones, okay? You don't have to go for real ones or square root or complex roots. Okay, let's get the pool first. P over Q needs to be determined by dividing what numbers? We first break 20. 1, 2, 5, 10, 20. Am I right? I missed one. 1, 2, 4, 5, 10, and 20. Agree? Agree now? They are the divisors of 20. About the divisors of 3. When this is not 1, I know there will be more and more candidates. It's 3, bad news. There are 2 numbers dividing 3, 1 and 3 itself. Okay. Next, we pair them up and form the list. 1 over 1 plus minus 1. 1 over 3 plus minus 3, 1/3. 2 over 1, 2. 2 over 3 plus minus 2/3. Oh my god, I have already 8 so far, and I'm done with these 2 yet. 4 over 1, 4/3. Here you go, you have 10 now. 5 over 1, 5/3. Keeps going and going. 10 over 1 and 10/3. 20 over 1. Look at this pool, it's crawling with fishes. How many? 2, 4, 6, 8, 10, 12, 24. How are you gonna catch one of them? that's gonna make this function 0 out of 20. So you need to be lucky. And help me, please. Which one you wanna test? Ugly, right? Try whole numbers, of course. Don't try to plug in 5/3 or synthetic division 5/3. Fractions are nasty to handle. So tell me a good one. I mean, what's your intuition telling you which one may smell like a 0? Give it a shot. Tell me one.
Four.
Okay, this one says 4. Let's test 4. I'll do synthetic division. Or you can just plug in 4. It's up to you. 3, 13, minus 3, minus 33, 20. Did I skip any? 3, 13, minus 3, minus 33, 20. 12, 25, 197. Why would you pick 4? That,
3 times 25. Oh wait, I see it. Never mind. I'm thinking 3 is
okay. 4 times 97 is 388.
Yeah.
Wow. Okay. 3,
It's not 4.
55. Yeah, I know this is 1300 something. It's not 0. Okay, good, we got it. At least we have one fish dead in the pool. Go for another one now.
-2.
Let's test -2. So you need to be lucky as well, not proficient in math. Luck plays a role here. Nope, you're not lucky. Right? I mean, double check my work, but not 0. This one failed as well.
Try 1.
Try 1, yeah. Why did we skip 1? I love 1. That's the... Always try the smallest values possible first. May work. Let's see if Courtney is right. 3, 16. Is that almost? She's not lucky as well. I wish this was plus. Did I make a mistake somewhere? Let me see. 3, 1 times 3, 16, 16, 13, minus 20. No, I wish this was a plus. Not 0. Sorry. Well, we almost missed it in the last step. Why don't we try -1? Maybe -1 works, huh? Right? Maybe not, I don't know. Aha, I was right. Yes. Right? Please double check. You caught one fish. That means you know one piece out of this long sequence of factors. It's gonna shrink our monster into a medium-sized monster, okay? How? Again, what I know so far is that polynomial 3x to the 4th plus 13x cubed minus 3x squared minus 33x minus 20 now has been, again, x minus 1 creates the factor x plus 1, So I have it right here. Now our polynomial is one size less, but how do I know that new piece? Where is it? How do I find this missing piece? It's here. Start from the end and write it up. Minus 16x plus 10x squared and plus 3x cubed. Okay? Okay? Now Hunt keeps going. Because you keep going until you get a quadratic function. Because this is cube, I don't know how to factor this. Do you know how to factor this on top of your head? Or can you use quadratic formula? No. So we need to keep hunting. You need to get one more fish, guys. Alright. I recommend test this guy on this function one more time because it can be a double root. It can be a root with multiplicity 2. Did you find one?
Up at the top, shouldn't it be negative 13? Like where you're 16, negative 3 plus negative 10.
Oh my god, is it so you're saying my work was wrong? Oh, you mean this positive one?
No, like the one we just did on the synthetic division in the middle, we have negative 3 plus negative 10. Like over the, yeah.
Oh my god. Oh, but I was still right?
Yeah.
Okay. Whew, that's a relief. So I was still correct here. That's the relief. Okay, at least we have one fish confirmed. Now I want to test x minus 1 if it's a double fish, I mean with multiplicity 2. If it also divides this thing, then we will get another x plus 1 from factors of this thing. And so I want to test this guy because it's our lucky fish, right? So let's test him again. For which polynomial? This one. For this one, okay? If it's a 0 of this remaining polynomial as well. So it's 3, 10, minus 16, and minus 20 is
minus 13.
Oh yeah, thank you. So minus 13. Thanks. Oh, that one. This one, right? Three minus 3 minus 13 positive 13 0 0 no. I wrote I made a mistake again. Slow down. I need to slow down actually. You're fine. Minus 3 7 minus 7 minus 20 positive 20. Yeah, there you go. This is a 0 one more time. In other words, my polynomial has a 0 with double multiplicity 2. That means not x plus 1 don't show up once, it showed up one more time for this piece, so they become a square. And what is the leftover piece? What is it? 3x squared 7x minus 20. Okay. Now, are you gonna keep fishing again? Do you want to test x minus 1 again? You can test x minus 1, or you can go with another fish from this big huge pool, but that will be a little bit waste of time because can't we do our own fishing here by manual factoring? Can you factor this manually? I bet you can do this one. The first term, x squared, will split up as 3x and x. I know for sure. I'm not sure about the pieces. I think you can find it. Come on. Chris?
Minus 5 and 4.
Minus 5 and positive 4. I will double check. multiply f, this FOIL, first terms, 3x squared, check. O, what is O? Outside terms. This is O, it's minus 20, check. And then I is inside terms, this is I, which is minus 5x. And then L is last terms, it's these two. L is minus, no, that's not L. I did L, F-O-I. I need to make I. So these are inside terms. So it's, no, I did I.
When you did the outside.
You got it, okay.
The outside.
Oh, outside terms. Oh, I forgot O. 3x times 4 is 12x. 12x plus minus 5x minus plus 7x. Yeah. When I FOIL it, it matches. So you guys found those two missing pieces without quadratic formula. Great. And this is it. We not only found zeros, also a full factorization of it. But we need to dig out the zeros now. What are the zeros? X equal opposite number. Set this into 0 and solve x equal minus 1. And this one is, take 5 to the other side, divide by 3. And that one is minus 4. There are 3 zeros, but this is multiplicity with 2. Multiplicity with 2, right? It showed up twice. So in total there are 4 kind of zeros, but 2 of them match. So this number, power, and the pieces of factors here always match. There are 4 factors, so yeah, x plus 1, x plus 1, 3x minus 5, and x plus 4. Sometimes same factor shows up twice. We call it multiplicity. You may have less numbers, different variety of numbers. Okay, let's put this in here. Rational zeros are minus 1, 3/5, right? 4. Y. Negative 4. It's 5/3. Okay, thank you. Good. All right, let's see what's coming up next. The next 2 problems are kind of shorter. What we did so far is we were given a long sequence of terms. We broke it into pieces and found its zeros that way. So there was a given polynomial, we found zeros of it. Here you are given zeros of a polynomial, but polynomial is missing. It's not there. You're gonna build that polynomial. Okay, so how do I do that? Okay, here is the fact. A polynomial is called f of x. I will call it the same, f of x. Can be formed by multiplying a number, x minus z1, x minus z2, x minus z3, x minus zn. If it has n zeros, you just simply take opposite of those zeros and combine with x, build each factor, multiply, and finally put a number in front. It's called leading coefficient. That's how you build a polynomial from its zeros. If you know the zeros, only thing you need to do is enter it. If you have n zeros, you have n many pieces. However, how many zeros are we given here? 1, 2, and that's it, right? And I'm going to take my eraser. There are only 2 zeros here and clean up the next, everything else, right? And besides, I need to double check the multiplicity of each zero. The first one is multiplicity 2. So how do I revise my setup? How do I reflect this into my setup? If it's multiplicity 2, this means showing up once. This 0 it shows up in the sequence once. If it is 2, I will put 2 here. Okay? This thing is 1. It's multiplicity 1, so I will keep it the same. And then I will simply enter those 0 values. First one is minus 5 over 3. Second one is 1 over 3. So the polynomial we are looking for is a number times x minus 5/3 squared x minus 1/3, and that's it. Mistake. It's plus because there is a negative and another negative in the 0. So they make a plus. Remember, what did I say? It's always opposite of this number shows up here. It's negative 5/3, it's positive 5/3. Are we done? Can we enter this into a result? There is still one unknown we need to figure out where. Where is it? A, yes, the leading coefficient. And how can I find it out? Some problems just say you can pick any leading coefficient you wish, then we go with 1 and multiply, expand this out. But here they have given us some extra hint or help. They say this function doesn't have a random coefficient in front. That when I enter 0 into function, you need to get 25. So that's what I'm gonna do. When I enter 0 into function, it becomes 25. So I will enter 0 everywhere and see what A needs to be chosen to make it 25. So A times, this is only 5/3 squared. This is negative 5/3. So it's 25 equals 25 over 3. No, that's 9. 25 equals A times 25 over 9. When I square a fraction, I need to square both sides. And negative 1 over 3. Alright, good news, I can divide both sides by 25 and these will cancel. Then I will multiply both sides by 27. This 27 will cancel these two. 3 times 9 is 27, right? So I'm canceling these. Okay? And still I have a negative sign. I need to multiply both sides by negative 27 so that this negative and that negative can cancel out. So we have it. A is negative 27. So the f of x that we are looking for in this problem is negative 27 raised to square of what? X minus 5/3. No, plus 5/3, right? It was this thing. And x minus 1/3. Alright, I believe the computer will not like this answer. It will ask us to FOIL and extend this entire thing. But I will give it a shot anyways. See if it's gonna like it. No, it did like it. Great. You don't have to expand this out. Okay? Alright, and the last question is related. You're going to write a polynomial this time. We are given that there are only two zeros given. One is a complex one. The other one is multiplicity 4. This is a little bit crazy. What can that polynomial be? Okay. It's A first root is, okay, there is some z1 and there is some z2, 0, 1, 0, 2. It looks like there are two zeros here, right? 4 minus 5i and 0. Okay, here's the thing with complex zeros. If one of the zeros is complex, you actually are given 3 zeros, because conjugate of that complex zero, which is, what do I mean by conjugate? Conjugate means you flip the sign in front of the complex part, make it 4 plus 5, is also 0. This is just a fact. Once a complex number is a 0, its conjugate should be also 0, because otherwise, think like this. There is some i's here and there are no i's on the other complex number, on the other root. If you multiply them, the result will have i's left out. No polynomial can have I in its expression. So we already know if there is a complex zero of a polynomial, and polynomial have real coefficients, its conjugate is also 0. So once I see a complex zero, I add a third 0, another additional 0 automatically, which is always the complex of it, conjugate of it. So the setup here is z1, z2, z3. The first one is x minus 4 minus 5i. The second one is x minus 4 plus 5i. And the last one is x minus 0. But that one has multiplicity 4. So I will put 4 around it. Make sense? Alright, we are not given anything else. No help given, no additional information given to solve for A. So we can choose this one, anything you wish. So what do you want to choose this one to be? What do you want to choose it? 1. Good. Alright, and then I will multiply this out. Okay, because since these are complex numbers, you need to multiply and clear them. And I won't touch this one. This is x to the 4th. So how do you multiply such a thing? Let me multiply here. Okay, I will FOIL it. F, first terms, x squared, right? O, outside terms, x with this parentheses. So it is plus x times that parentheses. No, it's actually minus x times minus is minus x. Minus x times that parentheses 4 plus 5i. And then minus I, minus times x times this parenthesis. So it's minus x times 4 minus 5i. And then L, last terms, minus times minus is plus 4 minus 5i, 4 plus 5i. And later, this is the multiplication, we have x to the 4th outside. well, it's a mess. Okay, but look what's going on. As I promised, all these i's must clear out. There should be no i's left. Look, this is x squared. Just distribute this minus 4x minus 5xi minus 5 xi. Now let's FOIL this. No, distribute this. Minus 4x, but this time plus 5xi. Guess what happens? These two cancel. And I have 16. I have 20i. I have minus 20i. This is plus. This is minus. And I have minus 25i squared and x to the fourth. Alright, 20i minus 20i cancels as well. And it looks like I was false. Minus 4x and minus 4x makes minus 8x plus 16. There is some I left, so I should have made a mistake somewhere. I promised you no I is left. This I is left, correct? Is that correct? What is I squared?
1.
I is root negative 1. Once I square it, square of root negative 1 is negative 1. I square is negative 1. So we already know this is negative 1. But minus 25 times minus 1 is, yeah, this is positive 25 when you multiply out. Okay? And add 16 to it, they make 51. No, 41. I promised you we will have no imaginary numbers, and I kept my promise. It's 41, right? Now you have x to the fourth. I will distribute this as well, and voila, we have our polynomial. I hope I did everything right. Have you checked my work? Okay, let's try it on. X to the sixth minus 8x to the 5 okay, once you leave the screen it's hard to go back. Let's clean it. Was this right?
Yeah, it's minus 8.
Minus 8? Okay, hold on, let me first. Oh, that one's right. Good. Any questions? Alright, the story we got here is if you have a complex 0, you consider its conjugate as a given 0 as well. So there are 3 different zeros given here actually. One of them has a multiplicity 4, so we ended up with 6th power. Alright, we're done for today. When you come back, we're gonna continue with 3.5 tomorrow.